Alrighty, we're going to take a look at a practical application to our exponent rules and see what we can figure out about the Earth compared to Jupiter in example 5. So we've got that the radius of Jupiter is about 11 times greater than the radius of Earth. That's a lot longer. How many times as great as Earth's volume is Jupiter's volume? And then we're reminded of the fact that a volume of a sphere, in general, what our planets are, nice and spherical. 4/3 pi r cubed is the volume formula. Okay, so it's almost natural to think, well, if the radius is 11 times greater, then the volume must also be 11 times greater. And it doesn't quite work that way just based on powers that come up in exponents. So let's take a look at what this would really be like. So if we imagine that we've got Earth right here, we can label Earth. I'm a visual person. I like the diagrams. Get the center. The radius means from the center to one of the edges. All right. So that length we're saying is r, is the radius for Earth. When it comes to Jupiter, we're talking a huge planet in comparison to Earth, still spherical, but from our center to the edge, we're assuming that this now for Jupiter is 11 times as great, or in other words, 11r, 11 of Earth's radiuses. So we want to use that information to compare their volumes. Okay, well, we're going to need a starting place. So let's start with Earth's volume. The volume of Earth is equal to, well, it's just a sphere. And so we're going to put in our formula. 4/3 pi r, and the radius is just r. So we're going to keep it as r. That's what the r stands for. Cubed. Okay, so that's the volume of the Earth. Well, let's try to write the volume of Jupiter. Okay, it's going to follow the same spherical formula, 4/3 pi, but instead of r, we know that Jupiter is 11r is what the radius is. So we want to put in 11r for that spot, and then it's still raised to the third power. Okay, so we have both of the equations written out. Now we can look at this Jupiter equation and recognize there's a little bit of simplifying we can do. We can start to use our exponent rules to help us simplify. So if we have two things multiplied together that are then raised to a power, we are allowed to distribute that power to both of the terms. So I'm not going to write out volume of Jupiter every time, but that's going to be equal to 4/3 pi, and 11 to the third is our first one. And so we should type that in, get what that value is. 11 to the third power is 1,331. And then r to the third power is just r to the third power. Okay, well, really all that this is, even though there's parentheses that I kept in here, this is multiplication between these two terms. This is just multiplying. It's just a string of multiplication. So for ease of looking at this, I'm going to write a little multiplication sign in between everything and take away the parentheses because they're really not necessary in this case. Okay, so if they're all multiplied together, it doesn't matter which order they would be multiplied in. I could put anything first, I could put anything last, just as long as each of them get multiplied. So I'm going to choose to put this 1,331 out in front, and we'll see what kind of results from doing that. So 1,331, and that is multiplied by 4/3 pi r cubed. Okay, well, 4/3 pi r cubed That expression right there probably looks a little bit familiar to us because that is the same as Earth's volume. Okay, based on the radius just being the radius, 4/3 pi r cubed. So we're going to replace that with 1,331. And we're going to replace this whole term with, that's just the same as what the volume of Earth is. That's what that expression represents. And so volume of Jupiter is what we've been solving for this whole time. We're trying to simplify the expression of. So this is saying that the volume of Jupiter is equal to 1,331 times what the volume of Earth is. So it's way, way bigger in terms of volume, way more than even just 11 times like what the radius was for volume. Now that it's a cubed value, it actually cubes that radius, how much the radius is greater. So 1,331. All right, I would write this out as a final solution of the volume of Jupiter is 1,331 times greater than Earth's. And that is what we were looking to solve for. Okay, so kind of interesting. We used our exponent rules, but ultimately we were using kind of a substitution, almost back to geometry type of feel, to figure out how many times greater.